MIT researchers developed a digger finger robot that digs through granular material like sand and gravel and senses the shapes of buried objects. Over the years, robots have gotten quite good at identifying objects as long as they are out in the open. Discerning buried items in granular material like sand is a taller order. To do that, a robot would need fingers that were slender enough to penetrate the sand, mobile enough to wriggle free when sand grains jam, and sensitive enough to feel the detailed shape of the buried object. MIT researchers have now designed a sharp-tipped robot finger equipped with tactile sensing to meet the challenge of identifying buried objects. In experiments, the aptly named digger finger was able to dig through granular media such as sand and rice, and it correctly sensed the shapes of submerged items it encountered. The researchers say the robot might one day perform various subterranean duties such as finding buried cables or disarming buried bombs. Seeking to identify objects buried in granular material, sand, gravel, and other types of loosely packed particles isn't a brand new quest. Previously, researchers have used technologies that sense the subterranean from above, such as ground penetrating radar or ultrasonic vibrations. But these techniques provide only a hazy view of submerged objects. They might struggle to differentiate rock from bone, for example. The team's first challenge was a matter of form. The robotic finger had to be slender and sharp-tipped. In prior work, the researchers had used a tactile sensor called gel sight. The sensor consisted of a clear gel covered with a reflective membrane that deformed when objects pressed against it. Behind the membrane were three colors of LED lights and a camera. The lights shone through the gel and onto the membrane, while the camera collected the membrane's pattern of reflection. Computer vision algorithms then extracted the 3D shape of the contact area where the soft finger touched the object. The contraption provided an excellent sense of artificial touch, but it was inconveniently bulky. For the digger finger, the researchers slimmed down their gel sight sensor in two main ways. First, they changed the shape to be a slender cylinder with a bevel tip. Next, they ditched two-thirds of the LED lights using a combination of blue LEDs and colored fluorescent paint. The final product featured a device whose tactile sensing membrane was about 2 square centimeters, similar to the tip of a finger. With the size sorted out, the researchers turned their attention to motion, mounting the finger on a robot arm and digging through fine-grained sand and coarse-grained rice. Granular media have a tendency to jam when numerous particles become locked in place. That makes it difficult to penetrate. So the team added vibration to the digger finger's capabilities and put it through a battery of tests. The researchers ran the vibrating motor at different operating voltages, which changes the amplitude and frequency of the vibrations. They found that rapid vibrations helped fluidize the media, clearing jams and allowing for deeper borrowing, though this fluidizing effect was harder to achieve in sand than in rice. They also tested various twisting motions in both the rice and sand. Sometimes grains of each type of media would get stuck between the digger finger's tactile membrane and the buried object it was trying to sense. When this happened with rice, the trapped grains were large enough to completely obscure the shape of the object, though the occlusion could usually be cleared with a little robotic wiggling. Trapped sand was harder to clear, though the grain's small size meant the digger finger could still sense the general contours of the target object.